America is returning to the moon. We are working alongside our many international and commercial partners to leverage the incredible capabilities from commercial industry to build a moon base. For all we hope to accomplish in this endeavor, what we are embarking upon is extremely challenging, and we know so little from what is a combined 80 hours of lunar astronaut EVA time across the Apollo missions, and that was more than a half century ago. So we are not jumping right into the glass dome moon base as a service. As we announced during the ignition event, we intend to take an iterative approach, sending a demand signal to industry for a lot of landers and rovers and tech demonstrations and all the scientific payloads these missions can accommodate. We are leveraging the NASA playbook from the 1960s, figuring out what works and what doesn't in this epic science of survival, because the moon base is as beautiful as it is hostile. In sunlight, the surface can heat to over 250 degrees. In darkness, it can drop well below minus 200. In the permanently shaded craters, areas of great interest that have been untouched by sunlight for millions, even billions of years, temperatures can fall well below minus 400 degrees. There is no atmosphere to moderate these extremes, no protection from radiation and solar particle events, and the surface is exposed to meteorite impacts, including the kind of light flashes the Artemis II crew observed from orbit. Recognizing this reality, I'm often asked why we send our astronauts into such harsh and dangerous and unforgiving environment of space or the lunar surface, and at such great cost. And we go for the technology we will pioneer to get there, the science and all that we will learn that will make life better here on Earth, to advance humankind on this great adventure, to inspire the next generation to do it better than we can, and to be very clear, to master the skills for where we will inevitably go next. I want to acknowledge the speed of the NASA Moonbase team and all those that are supporting this effort alongside industry to bring us to these announcements. So we are discussing 3 Moonbase missions and a series of additional awards with more missions to be announced in the months ahead. Now, Moonbase 1 will be the first privately funded lunar lander mission in history. The Blue Origin Mark I Endurance lander will deliver multiple payloads to the Shackleton Connecting Ridge, a strategic area of the lunar South Pole. In addition to flying 2 NASA science payloads, SCALPs, a lunar retroreflector array, the mission objective is to demonstrate critical capabilities that reduce risk for the human landing system missions. On that note, every mission in support of the lunar base helps us learn and de-risk crewed missions, but this one is especially important because of the role Blue Origin plays in the Artemis program. The target no earlier than launch date is the fall of 2026. Moonbase 2 will be the largest commercial payload delivered to the lunar surface ever, though in this Moonbase endeavor, we certainly hope to be breaking records on nearly every mission. The Astrobotic Griffin lander will carry more than 500 kilograms of cargo, including Astrolab's FLIP rover, to the lunar surface. This mission will help mature the capabilities necessary to support future lunar terrain vehicles, autonomous operations, logistics, and especially the LTV astronaut mobility. Moonbase 3 will expand our scientific understanding of the lunar surface. This mission will deliver the first payload selected through NASA's PRISM initiative, a program that brings together universities, researchers, and industry through open competition to solve scientific questions. The anchor scientific mission is Lunar Vertex, which will study lunar swirls, one of the moon's most intriguing mysteries. Now, these unusual formations appear brighter than their surroundings, as portions of the lunar surface are somehow shielded from the effects of the solar wind. Understanding why they exist could improve our understanding of how the lunar environment evolves, how surface materials change over time, and how future infrastructure may perform in these extreme conditions. The Moonbase 3 landings will also deliver payloads from ESA and the Korean Space Agency, demonstrating that the future of lunar exploration is an international effort. Moonbase 2 and 3 are targeted to launch before the end of 2026. Now, these represent the first of more than a dozen missions we expect to announce through the balance of this year as we return, build the base, and never give up the moon again. And as mentioned, just like in decades past, we are taking the world along with us, though this time, and eventually through the power of orbital observation and communication satellites, we will do so with impressive detail on the Moonbase website, which launched, I believe, in the last hour. The website will be a central hub for announcements, for mission updates, for imagery, video, solicitations, and procurement awards, and all the latest breakthroughs from NASA industry and academia. Now, just as the world paused to take notice of Artemis II and its historic mission, this website and all the associated moon-based missions will inspire students, instill curiosity, promote internships, and encourage them to work in industry as scientists, engineers, pilots, and astronauts to build hardware that will go to the moon and to control it from Houston. Perhaps even themselves to walk on the lunar surface as they grow up and carry the fire during the golden age of exploration. So for those waiting patiently, the grand return is close at hand, and we will not slow down. We are moving with the competence and the purpose to accomplish the missions that only NASA is capable of achieving, and we are really just getting started.